So today we will be talking about testing Ethereum smart contracts. I'll be giving a short introduction about the different techniques and tools and ways how you can do this. But first, a quick introduction. There are a lot of known people here from the blockchain world. I'm relatively anonymous. My name is Marko Kruljac. I work as a software developer and test at The Guardian. Basically, I'm a software engineer working in quality assurance. I'm focused on building high-quality software, and for the past couple of months, I've been collaborating on creating a decentralized algo trading platform. And that's about the relevant information that you need about me. So our agenda today is we'll make a brief overview about the state of testing smart contracts, where we are today. We'll revisit some traditional testing methods and apply them to smart contracts. We'll see some of the existing tools and some that are planned for the future. And hopefully this will help you create better, smarter smart contracts. So, where are we today? So, the first smart contract that was famously hacked is the Parity Multisig wallet. The attacker managed to take ownership of the wallet and withdraw funds in a total amount of 150,000 Ether. At the time, this was around $30 million. The damage would be even worse had it not been for a group of white hat hackers that somehow miraculously found out about the hack as it was happening. They actually stole the rest of the funds by the same exploit and returned them to their owners. So the first famous hack is Parity Multisig wallet. I guess they probably learned their lesson. Well, I guess they didn't. A couple of months after that, another incident broke out with the same guys. On GitHub, this issue was posted from this guy named Ghost. At the time, he was named DevOps 199. He posted that he found a bug in one of their smart contracts and managed to delete it. The implication is that, again, Parity Multisig wallet, he actually deleted a library that depends on this multisig, that the multisig wallet depended on, and he deleted the function to withdraw funds. The end result is that 500,000 Ether are frozen to this very day. About 2 weeks ago, there was a proposition to amend this bug by hard forking the network to return all these funds. This proposition didn't pass. So this is a headline from 3 days ago. A famous exchange suspended all token deposits because of a critical security bug which they called batch overflow. This is just basic integer overflow bug. So what happens, you can only store a limited amount of information in one integer, and they overflowed this integer and they created out of thin air an enormous amount of tokens. This is actually a very old problem that is solved with a safe math library, and just they didn't test integer overflows. So the granddaddy of all exploits, of all hacks, is called the DAO. At the time, 15% of all the Ether in circulation was lost, drained, because of a very, very simple bug. So the DAO is, you can think of it as some kind of ATM machine, I suppose, where you can withdraw funds, and the attacker, he crafted a very smart attack. He asked this smart contract to withdraw money, and the smart contract gave him the money, and as it was about to write in its memory that he gave this attacker the money, he crafted another request for the money. So the smart contract didn't know that he didn't have any more money, and he just gave him all this money indefinitely. luckily, we were able to mitigate this problem by hard forking the Ethereum network itself. It's a source of great debate, whether we are allowed to do this, whether we are allowed to change the blockchain, but we won't be really going into that. We are doing something okay, I guess, because EOS Crowd Sale has collected over hundreds of millions of dollars worth of Ether, and it's been running for 300 days and still no known exploit. So someone is doing something right. So I ask you again, where are we today? We have lost almost billions of dollars due to faulty code to do exploits. And part of the issue is that the tooling is still very young. Development of smart contracts is still very hard. By design, this is a type of program that you cannot patch. Once you deploy it, it's there. Bugs that are deployed are there. If you want to fix them, it has to be a hard fork. People don't like that. And testing smart contracts has been completely left behind. So in conclusion, I have to say that we are doing something wrong. I think we need to take a step back. So software has been here for a very long time, and we have traditional ways of testing software that are proven to work. So why aren't we applying them to blockchain? So what do we know so far? This is our entire knowledge about testing condensed in one pyramid with a cloud on top. It's actually a triangle. I don't know why people call it a pyramid. So at the bottom, you have unit tests. So this pyramid is all automated, and the cloud is manual work. And at the bottom, you should have unit tests, and the size represents the volume of tests that you should have relative to the other tests. So you should have most unit tests and the least amount of automated graphical interface tests. And let's jump right into it. So before you can start testing, you need to set up some kind of test environment. Obviously, you can test on the mainnet. This is very expensive. Every test costs you money. You can test on some kind of testnets like Ropsten and other testnets, but this is kind of slow. It takes about 2 minutes for a transaction, and it's public, right? If you have some kind of software that you want deploying and it needs to be private and you need to test it, you can't obviously test it on something that's public. So the solution is to test it on some kind of local private chain, and the solution to this is, one of the solutions is to use TruffleSuit. So TruffleSuit is a framework for developing and testing smart contracts that helps you in this process of setting a private, fast environment to run tests. So the first type of test is unit tests, and I think people have really forgotten how to write unit tests in Solidity. They don't write unit tests in general Web 2.0 technologies, much less in Solidity. So the idea is that you test some kind of unit of work, but the smallest possible unit of work, and this is often your method. And it should be used as a debugging tool, really. And it's great for that purpose, because you have a set of assumptions that can be really fast, and you can check them on almost every change to your code. So the best tool for running unit tests in Solidity is Truffle framework. So Truffle gives you the option to write tests in JavaScript using Mocha framework, and you can also write tests for Solidity in Solidity. So the anatomy of a good unit test, right? It should be automatic. This is fairly obvious, but I've seen tests that aren't automatic. So you should be able to press a button and you should get a response. Tests should be thorough. So they should have good coverage. They should not test the same thing twice. They should test every edge case. Often they don't. They need to be repeatable. So if you have a test that's passing today and failing tomorrow, This is obviously a very big problem because you'll be wasting time debugging why did your test actually fail today and not yesterday. And it's probably a sign of a bad test. Tests should be independent. This means that the order in which you run tests should be irrelevant. So they should not have any kind of dependency between them. And tests should only test one thing. So because you need a quick feedback, quick response, what is wrong with your code? If you have a test that tests 20 things, you aren't really sure what of those 20 things failed. They need to be fast. Because if you need to wait 10 minutes to get a response from your test suite, it's really 10 minutes when you're not productive. You don't have the information that you have a bug. And ideally, you should run your unit tests on every change to the code, to the save, not to the commit, not to the push, to the save. And if your tests run in 100 milliseconds, why not? Tests should be also professional. You should approach to them with the same level of professionality and responsibility as you would with any production code. So use logical variable names, do not repeat yourself, and all of the good practices that you apply when writing code should apply to a good unit test. But even if all unit tests are passing, you could have a ship that is completely sunk. So what's the problem here? You see the propeller is working, the chimney is working, that light over there is working, all unit tests are passing. But the ship went down. That's because just one type of test is never enough. Testing is like a filtered layered activity. You put one filter on top of the other, and you hope that in this way you will catch all of the different types of bugs. So the next type of testing is integration testing. No longer do you test your smart contracts in isolation. You just let them out in the wild on your private network wild, and you see how they interact with any of their dependencies. Truffle gives a nice solution here. You can just use it as you would for unit tests. A very good tool for debugging and testing is also Remix IDE. So it's an online editor. The best editor currently for Solidity is an online editor. So I think that just makes the point where we are in the development phase of smart contracts right now. If the online editor is the best one we have. So end-to-end testing. If you're creating some kind of decentralized application, you obviously have some kind of a Web 2.0 front end, right? Some HTML. And it's also important to test this part as well. But in my experience, this is still too cumbersome, too unapproachable to quality assurance, because you need to know all these things about blockchain, setting up a local chain, and it's quite difficult to set the initial state of this smart contract. But really at this stage, it's just an implementation detail, right? It's some kind of backend. It could have been a database. So this is something that still needs a bit of a work to approach it more to quality assurance. So, but these are kind of the traditional types of tests. Is this enough? It's not even close. So, does anyone know what mutation testing is? It's gonna feel great. Someone knows. So it's a type of test where you test actually the test. It's a test for tests. It's a really fun way. It's a fun technique where you change the source code in some kind of little way. Either you change the equals operator to not equals, or less than, you change it to a greater than. And you run your test suite again on this mutated code, this modified code. And what do you expect will happen? Well, obviously, if you broken your code with this change, the tests should fail, right? But sometimes they don't. What does that mean? That means you didn't really test that part that you changed. So this is kind of a test coverage indicator. To this day, I couldn't find any framework that does this for Solidity testing. You have it for Mocha. It's called Striker. It's a really good library, but not for Solidity. So we're kind of in the cutting edge as it is. Fuzz testing, also very interesting. So you have a smart contract that you attack with various random inputs that hopefully will make it self-destruct, make it freeze, make it send out money. And I found a framework. It's published on GitHub 10 days ago. 10 days ago. It's called Ongina? I don't know how to pronounce it. Probably, right? So this is their statement on the GitHub. It's quite alpha, and the API isn't guaranteed to be functional, let alone stable. So this is the world we live in testing smart contracts. Static analysis. So this is a little bit better field. This is the practice of testing your software without actually running it. So you kind of scan your code, be it Solidity, be it binary, and you search for known patterns. So these patterns can be security vulnerabilities. You can find performance issues. You can find gas issues. You could also use it as a linter. It's very good. Some of the tools that I found, Mithril, Mayan. So this Mayan is a really interesting tool. It's based on a research paper published recently by, God, I can't remember his name, but he works in Singapore. He has a Croatian name. So he created this very ingenious way of testing where it's a kind of a mix between static analysis and fuzz testing. He attacked almost 1 million smart contracts with random inputs, and he actually found out that some smart contracts, when given a specific set of inputs, give money to someone. He called this prodigal smart contracts. He also found out that some smart contracts with a specific input self-destruct. This is quite unexpected. He called them suicidal smart contracts. It's a really fun framework to test. So you also have Manticore, Rattle, but it's still in development. You have to apply for their waiting list. So we have War Games. War Games, it's not really a testing tool, it's a technique. It's a playground for testing your security skills. 2 months ago, none of this existed. So the best one is Ethernaut. It's by Zeppelin. You have like 10, 15 smart contracts that have a security vulnerability, and they present it to you with a challenge: go find the security vulnerability. Goat Casino, maybe 20 days ago, published on GitHub. It's the same thing. It's a smart contract with some kind of vulnerability. And you practice your auditing skill, your testing skills on these smart contracts. The last thing I'd like to talk about is formal verification. It's something that I've been doing since college, and I believe that this has no real-world application, that it's just for the academia. It's the process of checking whether a design correctly satisfies a set of requirements. Basically testing, right? But the really important difference is that this is backed by hard math. And there are a lot of different ways which you can achieve them. You know, you can have some complex formal mathematics to prove that your algorithm works. One of the ways to do formal verification is model checking. This is more of a hands-on approach, which I like because I'm not a researcher. So model checkers are specialized programs that exhaustively and thoroughly and automatically check whether some kind of model meets some kind of specification, right? You have a smart contract, and you model it in some kind of mathematical language, and you have a set of requirements. You model these requirements in some kind of formal language, and you run it against the model checker, and the model checker will tell you, does this model satisfy these requirements? And it will give you a counter example if it doesn't. So one of the model checkers that I used is called Spin Model Checker. It was developed in the 80s at Bell Labs by Gerald Holtzman. He was in the Unix team, so pretty fancy guy. He created also this language called Promela. It's like a C language in which you model your system, and you model your specifications using something called linear temporal logic. It's like Boolean algebra, but with some temporal modifiers like this variable must always be true, or eventually it must be true. So using these two modeling languages, you can create a model of your system. You can give it some specifications, and you can see if this holds. So I tried, for the fun of it, to model the DAO smart contract using Promela, and I gave a very simple LTL specification, which says that the user's money on his wallet should never be greater than his initial funds and the funds that he was allowed to withdraw. So if you started with 2 Ether and you were allowed to withdraw 2 Ether, you should never have more than 4, right? Well, it turns out that you can't have more than 4, and this program finds this kind of bug. So why aren't we always doing this, right? Well, getting the model is very hard. It's actually harder than to write the smart contract. And you can easily be wrong. So you're investing a lot of time into something that might not always work. And the complexity of modeling this grows exponentially to the complexity of your system, which is kind of okay for smart contracts because they're, 1,000 lines of code. Imagine formally verifying, Ericsson or something like that. No way. But there's still a lot of work. The process of converting your Solidity program into a Promela model is also error-prone, and it takes time. I'm working on a compiler that will do this automatically, hopefully also formally verified. And the idea is you could just feed this system with thousands of smart contracts and a couple of requirements, and it would test it exhaustively and in a very short amount of time. So that's all from me. Thank you for listening. Any questions?
So just a short one. Do you see the light at the end of the tunnel?
I get that asked a lot. Generally, when you see the light at the end of the tunnel, it means you're going to die. I don't like seeing lights at the end of the tunnel. I think that we have hope. We have tools, techniques that work. We just need to take it a bit slower and apply the same standards to building smart contracts as we would to traditional systems. I think we have the notion that we have to publish things fast, and because of that we're cutting corners and mistakes are happening and millions of dollars are being lost.
How can you be sure that your model correctly represents your smart contract?
You can't. It's almost as difficult as modeling. Well, you could create this compiler, and you could prove that if the compiler is correct, then you have some kind of certainty that the model will also be correct. But proving that the compiler is correct is extremely difficult. So you can never really be sure, and this is part of the reason why this isn't used in mass. It's more of an academia exercise in thought process, because you can easily get it wrong.
That's it?
Okay.
Hey there.
Hi.
So, have you used Multicore previously, and have you used it on a system of smart contract? Do you do a static analysis for every smart contract one by one?
No, I haven't used Manticore. I use most of the tools. Manticore and Mayan are still on my bucket list, but we have a couple of smart contracts that we are testing. So we don't have to have something that can test en masse. We are focused on a very specific set of smart contracts, and we will definitely be testing them with all these methods.
Any more questions?
Okay. Thanks.